All right, everybody, so today we are talking about the surface area and volume of prisms and pyramids, so things that deal mostly with squares, rectangles, and triangles. I know we've talked about cylinders, cones, and spheres so far. You'll see a lot of similarities, but because these don't have those round edges, we don't use the circumference equation for any of these. We're going to base it all mostly off of these first few things. We've got our area for triangle, our perimeter and area for squares and rectangles, as well as our trapezoids that we have there too. So let's get into this. Let's talk about our rectangular prisms, in other words, our cubes. So the things that are made up of only squares or rectangles. And if we have the surface area for that square rectangle, right, we're looking at the area of these shapes all combined together to make one large surface area. Well, remembering back to the area for a rectangle, we have our length times our width. And that changes to side squared when we talk about a square because the length and width would be the exact same measurement. Now, when we think about how a rectangular prism or cube is different from just a rectangular or square, remember that we now have that extra dimension of width added in. So we would actually have to have a combination of all of those different parts added and multiplied together. So we would have length times width to get the area of the bottom and the top rectangle. So there's our 2 length times width for that one. We would also have length times height to get the 2 sides here. So that's 2 length times height. The last one, our last 2 sides, are these edges here, and that's by the width and the height, and there's 2 of those. So that's how we get that surface area. So let's calculate this. If I have this rectangular prism here, it doesn't really matter where I put these numbers in as long as I make sure I have all those combinations. So we'll say 7 here is the width, 13 is the length, and 9 is the height. All depends on the orientation of how this rectangular prism would be laying or resting. In this case, I think this makes the most sense for me. So we'll have 2 times 13 times 7 plus 2 times 13 times 9 plus 2 times 7 times 9. And that's going to give us our surface area. You can multiply all of those together and add them all up in one long continuous line. So if we grab out our calculators here, there we go. Typing this all in, we'd have 2 times 13 times 7 plus, actually I think I'm going to do this in a couple of steps. All right, so we get 182 there. I'm going to do this in a few steps just because there are so many numbers. 2 times 13 times 9, 234, and then add 2 times 7 times 9, which would give you 126. And now we're going to add all of those together. And when we do that, 234 and 182, we would get the surface area is equal to 542. And remember that our units are whatever our measurements here are squared. So feet squared. Again, that works for anything that is similar to a cube or a dice shape, something that's made up of only rectangles and squares. But sometimes we'll have what's called our other prisms. They're made up of not just rectangles and squares. They could be triangles in the mix, trapezoids, any of those different kinds of shapes. Now, the way that we would find the surface area for these is by knowing the perimeter of our base and using that to find our area of these other shapes as well. So all of these are going to obviously have 2 tops or 2 bottoms, 2 bases, just like so. And you can see our equation over here is going to be the height times the perimeter plus to base, but that perimeter is the perimeter of the base, not the perimeter of all the shapes, just the perimeter of the base. So when I take a look at our first example here, we know that we have 15, 9, and 12 around that based triangle. And our height is 16. So to find the perimeter of the base, what we would do is we would take and we would add all of those sides together to get the perimeter around our base. So we would want to find the perimeter of the base. So we would get our perimeter, P, that base, is 9 plus 12 plus 15. Now you might be missing an edge on one of these triangles in the future. Know that we can use the Pythagorean theorem, or we can use what we've talked about with sine, cosine, tangent, those different things to figure out the other sides of our triangle. So we have other tools in our toolkit to be able to find any missing sides that we have. For this perimeter, we would specifically get 9 plus 12 plus 15, and so our perimeter base is going to be 36. So if we get a base of 36, then we can use our surface area equation here by plugging in the height between the bases, so this 16 here, it's our height between the bases. And then we need to find the area of the base, though, for this capital B here. And so remember, the way to find area for our triangles is 1/2 base times height. Doesn't matter what your triangle is, 1/2 base times height. So let's find that B, 1/2 base times height. And for this triangle here, we're not looking at the hypotenuse. We're specifically looking at our two sides that make the 90-degree angle. So we have 1/2 9 times 12. Which would give us 54. All right, so we have all of our parts now. We can use this surface area equation. Surface area equals HP, so 54 times 36 plus, oops, not 54, my bad, that should be 16. 16 times 36 plus 2 times 54. And so we're going to plug that into our calculator, and we'll take 16 times 36. And I know that 2 times 54 is 108. And we'll get our surface area is 684. And remember, we want to label this with our units, and surface area is always the units squared, so meters squared. You can follow the same steps for any of these other shapes here. Any one of them that you solve for, you should end up with the same idea. We want to find the perimeter of the bases, so base here, this one's the base there. And that'll help drive the rest of solving for those prisms. But now, what happens when we want to find the volume of these shapes? Well, thankfully, these are a little bit less complicated than our previous shapes that we looked at, whereas maybe the surface area was a little bit more complicated. For the volume of prisms and cubes, we're basically just going to take all of the side lengths and multiply them together. So for our rectangular prisms or cubes, that's just length times width times height. I think we've all heard that one before. So we have our first one here. We would take our length, 17, our width, 9, and our height as 24, and multiply those all together. So that would give me 17 times 9 times 24. And so I'm going to use the calculator for that one. 17 times 9 times 24. And I'm glad I did, because we get 3,672. And remember, it's always units cubed. All right, I think we all knew that how to find volume of rectangular prisms and cubes. But the other one that might be a little bit trickier is to figure out the volume of these other prisms, right? Things that are made up with triangles or trapezoids. So let's talk about some of these. If we look at the prisms here, we have our base and height, but B this time stands for the area of the base. So kind of similar to last time, we still want to find the area of our base. And then H, the height between the bases. So how far up does that go? So let's just talk through this first one here using that triangle. So for this one, I need to find the area of this part down here. Well, it's a little bit more complicated than that, because in both cases here, I know that this full side length is 12, but I need to know just the partial. So I am given the height, which is 7.3, and this top is the same as this bottom side here of 12. So the area of my base, my capital B, is 1/2 7.3 times 12. So now for this triangle here, we would plug that in for our calculators. And we would have 0.5 times 7.3 times 12. And so our base would give us 43.8, and that is feet squared, just so that we're keeping track of all of our units. And now we're going to multiply that by the height between our two bases. So we know that it follows this shape the whole way up, all the way up. And we know that it needs to fill 5 feet high. So that's where we get our volume equation from here. And so our volume is base times height, which is 43.8 times 5. And so taking that 43.8 times 5, we would get 219. And remember, volume is always feet cubed. All right, so we've talked about these prisms here. You're basically just going to break them up into the different size shapes that you know and can find. And once you have figured out those bases, you're able to really find a whole lot more with these. Let's move on now to the last shape we're going to talk about, which are pyramids. All right, so for our pyramids, we're going to talk about surface area and then volume, just like we have been. And so to find the surface area here first of our pyramids, we want to note our formula, 1/2 LP plus B. Well, we talked about this with the last shapes. P is the perimeter of the base, and capital B is the area of the base. So the only other thing we need to talk about is this L. L is the slanted height, not the straight up and down height that would come down the center of the pyramid here, but the slant that follows that angle that the pyramid comes down at. All right, so let's take a look at maybe something that would be a little bit more challenging of an example with this one. Let's take a look at number 3. So if we look at number 3, you'll notice that this triangle here only gives us the middle height. It does not give us the slant for our L. Well, we can find that though, because we know the center of our triangle is halfway through. And this side here is 16. So halfway through this side would mean that this is 8. So to find our hypotenuse, we can use that Pythagorean theorem. And we would say that 3 squared plus 8 squared equals C squared, or in this case, L squared. Well, 3 squared would give me 9, 8 squared would give me 64, and add those together, I get 75 for L squared. But I don't want L squared, I want just L. So if we take the square root of that, it's going to be 8 point something, so square root of 75, 5. And we get 8.66. I'm going to keep that extra decimal place just to be a little bit more precise. All right, so we've found the slant height. Now we need to use that to find the surface area of our shape. Oh, there's a couple other things that we need to solve for first too, though. We need to find the perimeter of our base, which thankfully it looks like the base of this must be a square. So we can take 16 times 4 to get the perimeter, which would give us 64. And then the area of the base is 16 times 16. In other words, 16 squared, which would give me 256. All right, so we've found all the parts. Now we can plug it in for our surface area equation and solve. So the surface area of this here pyramid is going to be 1/2 L, which is 8.66, times our perimeter of the base, 64, plus our area of the base, which is 256. So typing that into my calculator here, we'll get 0.5 times 8.66 times 64 plus 256. So I get a total surface area of 533.12. That rounds to 0.1 pretty nicely. And surface area, just like area, is always our units squared. All right, so using a little bit of other information that we know to figure out the other parts of this triangle. So if we have a triangular base here, you know how to find the base and perimeter of a triangle, any other regular shape as well. Really just kind of depends on the shape you're given, on which equation you're going to use. Let's talk really quick about the surface area of this pyramid. Remember that we have the area of 4 triangles over top of 1 square. So in this case, we're taking the area of those 5 triangles, which we know the area of a triangle is 1/2 base times height. And we have 4 of those. And we're adding on the area of a square, which is just base times height. Now, this gets a little bit more complicated based off of the triangle shape that we're given here. And the reason why it gets a little bit trickier than just something like this is because of the way that the triangles are going to slant. So the angle makes this a little bit different, but you can see how these shapes here would relate to how we use our equation here. So this would give us 2 base times height but like I said, these bases and heights are 2 different things. So we'd have to make sure that we maybe would say this would maybe be length times width instead. So not necessarily always this exact case, but it could definitely be something similar to that if you were maybe to have a triangle or a pyramid made up of only triangles and those triangles were all equivalent. You would have something similar to this. Let's take a look now, though, at the surface area for these pyramids. All right, last shape, last round, here we go. Pyramids and their volume. So now our volume equation is very similar to that of what we saw from our rectangular prisms. Just like when we compared the cone to a cylinder, you'll notice that this is actually 1/3 of what our rectangular prisms had for their volume. And that's because a pyramid, you can show a proof that says that that pyramid is 1/3 of the volume that your rectangular prism would be with the same base and height. So we can prove that maybe another time. For right now, let's just talk about using this. So if we have our equation here, let's go ahead and just use this first example. So we want to find the area of the base first. Well, the base here is a 10 by 11, so we'll take 10 times 11 to get our area. which will give us 110 for our base area. And then we're going to take and multiply that by the height. This one's nice because they give us the height, but if we were given something other than that, if it was the slant this time, we can still use that equation of the Pythagorean theorem to find the middle height of our pyramids. Remembering that halfway through here is half of the side, so that would be 7, and then we can find the height by using the Pythagorean theorem. So the height here was given to be 16, and so we know volume is 1/3 of 110 times 16, and we'll go ahead and use the calculator for this one. 1 divided by 3 times 110 times 16, and so we get a volume of 586 points, we'll round that up to 7, and inches cubed for volume. Again, I'm not going to go through more examples here. I think we understand how to find those other shapes and things. Remembering that if we need more information on those, you can always refer back to your reference sheets with all of that other information and being able to find those other parts. So with that, if you have any questions, you need a little bit more help with this, always send me a message, send me an email, let me know. I'm happy to help. Have a good day.